David was a member of the Institute for 15 years and served as past president of the New South Wales Committee, as a representative on National Council, and as a director. David has been involved in the concrete industry for over 25 years since graduating as a civil engineer from the University of Sydney, and is committed to working towards the Institute's vision of excellence in concrete.
On behalf of the Concrete Institute of Australia, thank you for downloading this eConcrete presentation. The presentation is on recommended practices in concrete durability, and at this point I will make special mention of Mr. Rodney Paul from GHD, who is our Durability Committee Chair, and also Mr. Frank Papworth, our previous Durability Chair, who have driven a considerable amount of work undertaken by this committee over several years. I'm sure that we all understand that getting durability right is vital. The built environment represents a huge investment for any organisation, government and country, and the more we spend on repairs and maintenance of assets and infrastructure, the less we have to spend on other aspects of everyday life, such as health and education. As the second most used material in the world behind water, a very large proportion of our built environment is made of concrete, and so it's vital to understand this important material. In many countries, this has become a major issue as they move more from construction of new structures to the maintenance and restoration of old structures. This adds a new dimension to durability design. Because concrete is a complex material, research into the cause of problems and the development of appropriate rules and operational methods has taken a long time, and continues to be a difficult issue to design and manage due to many variables. Whilst research into concrete durability continues, the knowledge on exposure significance, deterioration processes, materials properties and workmanship implications has developed significantly over the last 25 years. In this time, new durability design practices have been developed, including durability modelling methods and new methods of construction, which have been introduced. However, have these developments been fully reflected in a clear and unified manner through the codes and guidelines dealing with concrete durability requirements? In Australia, durability requirements in Australian standards are fragmented through different standards and their commentaries dealing with concrete durability requirements for different structure types. Essentially, in Australia, there are two sets of codes: the various materials codes, which cover the necessary requirements to supply and apply particular materials, and structures codes, which outline how to apply the materials available in design. However, the main issue lies with the structures codes. Perceived conflicts between these documents, for example, the covers in AS 3735 for liquid retaining structures, are higher than those in AS 3600 concrete structures for the same life and exposure. And these might sometimes be explained by the different owner requirements, but reasons for the differences are not given and the associated assessment methods are not clearly stated. Other issues include, but are not confined to, limitations in exposure classes and materials, differences in deemed to comply requirements to be more certain of achieving durable concrete, strength being used as the main durability determinant and no allowance made for supplementary cementitious materials, water cement ratio, steel type, admixtures or coatings, and little information on the effect of quality practices such as curing. The fragmentation of the standards and a push from leading durability experts in Australia led to the formation of the Concrete Institute of Australia's Durability Committee in 2008. The outcome of their initial work was that a comprehensive and unified durability guidance was required. In response, the Durability Committee established task groups to produce a series of recommended practices as a major revision to Z7 that would form a durability series. This series, known as the Z7 Durability Recommended Practice Series, includes Z701, Durability Planning, Z702, exposure classifications, Z703, deemed to comply requirements, Z704, good practice through design, concrete supply and construction, Z705, durability modelling, Z706, concrete cracking and crack control, and Z707, performance tests to assess concrete durability. At present, 4 of these documents, planning, good practice, crack control and testing, are complete and available. 2 of the other documents, exposure classes and modelling, are due to be completed by the end of 2018, whilst deemed to comply will be finished in 2019. Already, the durability planning document has been recognised globally as a world first in providing a guideline for the planning processes required, and the subsequent documents are all part of the larger suite to ensure concrete durability is well planned, designed, constructed and maintained. When looking at the various documents to be produced, the committee identified the variabilities of the definition of durability in codes, particularly within the Australian standards. The Durability Committee settled on the following definition, and this is used consistently throughout the documents. Durability is the capability of structures, products, or materials continuing to be useful after an extended period of time and usage. In the context of performance-based design of structures, durability refers to the fulfilment of the performance requirements within the framework of the planned use and the foreseeable actions without unforeseen expenditure on maintenance and repair. This variability in definition extends to the way design life is defined. From a durability design perspective, it is one of the most important parameters required by any asset owner. However, it is very rarely clear. Often it is also confused with the term service life. The Durability Committee determined to look at design and service life together, but also look beyond the design service life and consider what happens after service life has been prolonged. The committee referenced the figure shown, which is taken from the FIB Bulletin number 65, which focused on the final draft of the Model Code 2010. It looks at the phases in the life of a structure and takes into consideration design, construction, and operational service life periods. The first guideline that the committee felt was important to complete was the durability planning document. The reason for this is that whilst information on concrete deteriorating is available for analysis, there has been a gap in the formal processing required to achieve durable structures in design, construction and operational maintenance. Durability planning outlined in Z701 is a system to formalise this process. Z701 sets out the process of planning to achieve the required level of durability. The durability planning outcomes are then delivered in a durability assessment report or durability plan specific for the particular project. It describes how the desired level of durability will be achieved using appropriate tools and recommendations given in codes, standards and recommended practices. Why do we need this? All capital works, whether government or privately owned assets, must achieve an intended design service life, operational functionality, acceptable return on capital investment, safe operational environment and environmental sustainability. By having in place an appropriate durability objective throughout the project, this will then allow all of this to be delivered. Traditionally, from a structural design perspective, as mentioned before, we have taken for granted that concrete is a durable material. However, as we know, this is not always the case, particularly in harsh environments or in changing environments. The lack of clarity among various standards and codes does not help this, as it can lead to confusion, differences of opinion, and ultimately compromised construction. Incorporating specific durability design processes into the structural design, choice of materials, construction methodology, and the operational maintenance program means a clear, well understood plan is in place to achieve the expected durability outcomes of the project. Examples of concrete structures recommended to use durability planning include, but are not limited to, major civil and building structures such as bridges and tunnels, buildings of all types in environments likely to create durability issues, mining and industrial structures, wharves, piers and jetties, water retaining structures such as dams, tanks and treatment plants. Also precast panels with complex requirements, buildings with applications that lead to unusual exposures, industrial sites where elemental structures might be exposed to contaminated ground or air, and all concrete structures in corrosive exposure environments. The next document completed was Z704, Good Practice Through Design, Concrete Supply and Construction. The reason that this document was produced is that Australian concrete construction standards have traditionally been more generally focused on minimum design and material requirements and are unlikely to provide more informative recommendations about how to design or construct a structure to get the expected service life. The objective of Z704 is to provide these informative recommendations. It provides more specific detail with respect to durability considerations in areas such as the impact of specifications and the contract process, impacts of design on construction, more detailed view of the materials used in construction, material quality control processes, construction process and supervision, as well as some detailing issues in common structural elements that may present potential durability issues to the designer and constructor. These matters are considered under a number of categories so that the designer, the durability consultant and the contractor can understand the importance of the impact material properties can have on durability and consider how these properties can be delivered during the construction process. Z704 is intended to inform all parties involved in design and construction about the benefits of durability planning and subsequent control of implementation so they can deliver the expected level of maintenance and life of the structure to the asset owner's requirements. Cracking in concrete is probably the most challenging subject we continue to face when it comes to durability. Thus, it is important that the suite of durability documents covers this subject specifically, and Z706, Concrete Cracking and Crack Control, does just this. Cracks in most concrete structures are to be expected, but the challenge is to ensure that they do not have an adverse effect on the serviceability and durability of a structure. Z706 provides up-to-date guidance on concrete cracking and design for crack control for structures, as well as guidelines for the assessment, monitoring and repair of concrete. It is hoped that it will form the basis of improved design procedures for crack control, improved construction practices to minimise plastic cracking, and a consistent approach to the assessment and repair of cracks in concrete structures. Australian codes handle cracks by limiting the stress in the steel, and this approach was said to be developed to keep crack control design simple for the designer. More likely though, it was developed because no one wanted crack widths to become part of specifications. Z706 deals with crack width design. When it was originally developed around 30 years ago, one of Australia's senior experts at the time noted in the Australian standards that there were few cases where the stress limits would not be adequate. For example, thick elements with high cement contents. Today these exceptions are much more prevalent. Durability designers are also focused on the allowable crack width in different exposures, and so crack width design has also become important for this. Hence, Z706 includes limits on use of steel stress approach, background to thermal, shrinkage and load-induced strains, Syria C660 for thermal strains, and an Australian approach to shrinkage, restraint and live load strains. The fourth completed document is Z707, Performance Tests to Assess Concrete Durability. It takes into consideration that a wide range of tests that have been introduced over the years, all designed to demonstrate the potential durability performance of concrete, that has led to some uncertainty in the various areas. Z707 aims to consider the current design guides, codes and Australian practice to provide advice on preferred methods of testing concrete in particular circumstances to demonstrate the durability performance of a structure to meet design life intent as set out in the project specification. Whilst considering the recommended tests that are suitable for project specifications, the guideline looks at the design phase, the construction phase, and the operation and maintenance phase. At the design phase, it is suggested that the test methods available to assess various aspects of durability performance through a concrete structure's life cycle include mix acceptance tests to confirm suitability, tests for quality assurance, tests at the end to determine if placed concrete is suspect, tests for condition monitoring. In the construction phase, it's recommended that materials testing and selection be completed in accordance with the project specifications prior to use in the works. Additional testing is required prior to a change in supply of materials or a new source of materials. It should be remembered that verification of concrete mix designs to meet project specification durability requirements can take considerable time. For example, durability testing of concrete, such as chloride diffusion or water permeability, may have test periods of up to 3 months. Variability of durability tests must be taken into account by the durability consultant, with specification test criteria allowing for alternative solutions to achieve the required durability if the test results do not achieve the specified values. Under the operation and maintenance phase, monitoring and testing is recommended. For example, practical completion inspection prior to a structure going into service to determine if any defects need to be repaired, and initial structure characteristics and condition documented. Periodic in-service visual inspections, particularly on small projects, to ensure that minor problems don't become large ones. And in-service condition monitoring and testing to prevent or delay the onset of corrosion initiation. This usually requires regular inspections in conjunction with additional activities such as structural monitoring and non-destructive testing. There is a lot that is covered in Z707, and in summary it provides guidance on concrete mix acceptance tests for durability design and construction, tests for quality assurance during construction, tests where placed concrete is suspect, and tests for condition monitoring. To overcome these problems, Z72 will look at defining different exposure classes for different types of deterioration mechanism and exposure conditions, irrespective of structure type. These have been based on the FIB Model Code 2010 and ISO 16204 classifications. As a large proportion of deteriorated concrete structures are related to reinforcement corrosion, Z705 durability modelling only deals with modelling of corrosion of reinforcement. It takes into account the 4 typical approaches to durability design as identified in the FIB Model Code for service life design and looks at how durability modelling can be used, what models should be used, and when modelling should be used. The key objectives of Z705 are to review the commonly used models for prediction of reinforcement corrosion in concrete structures and input parameters for chloride diffusion, carbonation, and corrosion of reinforcement, including stress tendons, and to determine the most suitable models and input parameters with relevant statistical distributions. Considering the complex nature of reinforcement corrosion and other concrete deterioration processes, and future data from ongoing research, Z705 will always be a work in progress when new understandings and developments justify review. The final document that will be completed is Z703, deemed to comply requirements. The reason it will be the last to be completed is that it will take into consideration all of the durability documents and will be based on minimum cover requirements. It is expected that the minimum cover depths will be determined by a reliability approach that takes into account the decreasing rate of ingress of many aggressive agents with time and will provide solutions for exposure conditions not adequately covered by current standards and codes. In summary, the service life required from concrete structures will only be obtained if specific consideration is given to how durability requirements impact on construction cost, inspection needs, maintenance requirements, and operational and community costs that unplanned maintenance brings. While strong emphasis is placed on achieving the design life, durability must be met long into the future, possibly well past the initial design life. The Z7 Durability series of recommended practices will go a long way to providing the necessary tools for design and construction of durable structures based on the latest understanding of exposure, materials, and deterioration process. Where can you learn more about these documents and the background behind them? The Institute has a comprehensive webinar available on our eConcrete online learning portal that includes the 7 task group leaders who have or are driving these documents. It includes the presentation slides and audio of the speakers, and the package can be purchased to include a comprehensive set of notes that are also available to complement the online portal. Alternatively, Z701, Durability Planning, Z704, Good Practice, Z706, Concrete Cracking and Crack Control, and Z707, Testing, can be purchased in hard copy from our online bookstore or downloaded in PDF if you are a member from our resource centre. In closing, thank you again for downloading this presentation, and feel free to see what else the Concrete Institute of Australia has to offer at our website.